Hello, this is Andy Chapman from Insight Partners, and today we're going to talk about control strategies for dedicated outside air systems, and specifically the control logic we use in order to deliver neutral temperature air. So these machines have four modes of operation: cooling mode, heating mode, dehumidification mode, and vent mode. And we use the entering air conditions as sensed by a temperature and humidity sensor of the evaporator to determine which mode of operation that we're going to be in. We input 3 set points into the controller to psychrometrically determine which mode of operation we're going to be in. The first set point is the cooling mode enable set point. If the entering air temperature climbs above this set point by 1 degree, we're going to go into cooling mode. The second set point is the heating mode enable set point. If the entering air temperature falls below this set point, we're going to go into heating mode. And the third set point is the dehumidification mode enable set point. And if the outdoor air dew point climbs above this, then we're going to go into dehumidification mode. We will enter into cooling mode. We're in this bottom right-hand corner of the psychrometric chart, where the air is warm but dry. In order to deliver neutral air, the compressors just need to modulate in stage in order to achieve the supply air cooling set point of 75 degrees, which would provide you neutral temperature air. Heating mode would be entered when we're in the bottom left-hand corner of the psychrometric chart, when the air is cold but dry, where heating would be modulated and or staged to achieve the supply air heating set point as sensed by our supply air temperature sensor. We're just going to warm the air up back to the neutral condition. Dehumidification mode takes priority over all of the modes and can exist anytime the outside air dew point is 2 degrees above the dehumidification mode enable set point. In dehumidification mode, the compressors are going to modulate and or stage to achieve the evaporator coil suction temperature set point as sensed by the suction pressure transducer, typically set at 40 degrees. We realize that there's a 10-degree approach between the evaporator coil temperature and the leaving air dew point. The modulating hot gas reheat valves are then modulated to achieve the active supply air temperature set point, whether that's heating mode or cooling mode. The vent mode is our Goldilocks scenario, where the air is between the heating mode enable set point and the cooling mode enable set point. The air is already perfectly neutral and ready to be delivered to the space. No mechanical cooling or heating is required. When specifying a dedicated outside air system, try to remove the term thermostats from your specifications and schedule notes. Thermostats are simple devices and they only have outputs to energize a fan, a compressor, or heat. They are not sophisticated enough in order to control a dedicated outside air system. Instead, try to use the terminology configurable or programmable direct digital controller. Your controller needs to be sophisticated enough to monitor supply air temperature, outside air temperature and humidity, refrigerant suction pressures, refrigerant discharge pressures. It needs to be able to modulate things like a modulating hot gas reheat valve or condenser fan speed in order to maintain stable refrigerant pressures. This sequence of operations and more are talked about in our dedicated outside air unit design seminar, where we can teach you step-by-step how to size your outside air unit, specify and control it. If you'd like an in-person seminar or an online webinar, feel free to reach out to me and we can get something set up for your firm. Thanks for watching and have a great day.